Alright, today we're going to be talking about how to get quantum numbers. For the principal quantum number, you can get it either from electron configuration or the visual way, or it's a given. So let's say we have a hydrogen atom. This hydrogen atom has one electron and one shell. So this electron, the principal quantum number is 1 because it's in the first shell. If it were to be n is equals to 2, it would be in the second shell, and so on. The possible values of n are 1 to 4. So 1, 2, 3, and 4. Now you can also get n with the given electron configuration. For example, let's say we have 5s. Let's do it angular first. So we and let's go back there because you need to know angular to get the principal with the electron configuration. So in angular, basically L is less than or greater than n minus 1. So the possible values of L are 0, 1, 2, and 3. These are the possible values of L. So these numbers, they correspond to an subshell or the orbital. So this is 0 is s orbital, 1 is p and d, 2 is d, and 3 is f. So if we go back here, we have 5s. What? Rose up. 5s. 5s7. To get the principal quantum number here, we can go to our angular and say that since it's s, it's equals to 0. And since L is equal to n minus 1, we can add 1 to 0 to get n is equals to 1. Wait. So S corresponds to L equals 0. L is greater than n minus 1. So we can substitute L with 0. So 0 is n minus 1. And then we can transpose this to get 1 is less than or equal to n. So by default, n is 1 if it's s. Yeah, that's just a fun math thing. Yeah. Anyways. So for example, let's have n is equals to 2. So L is less than or equal to n minus 1. So L is less than or equal to 2 minus 1, which is just 1. So the possible values of L here are 0 and 1. For the magnetic, we use the L. So L is equals to negative L to positive L. So it's a range. So for example, L is equals to 1. M can be ML. ML is negative 1, 0, and 1. For the spin, it's either positive 1/2 or negative 1/2. You just need to base it off the orbital diagram. So this is when it's up, it's positive. When it's down, it's negative. So for example, let's have 5s7. So from S we can get L. So L is equals to 0. And add 1, so L is equals to 1. N is equals to 1. ML is equals, wait, what? Wait a minute. Sorry. I did not mean S. I meant 5D. There we go. So D is equals to L equals 2. So L is equals to 2. And then plus 1, so N is equals to 3. ML is equals to -2, -1, 0, 1, 2. Then we can make the orbital diagram. So this, and then we need to put 7 electrons. So 1, 2, 3, 4. Wait, D. What am I correct? Yeah. Huh? Can D hold 7? Yeah, okay. It can. Okay, there you go. 1, 2, 3, 4, 5, and then 6, 7. And since this is the last placed electron, the downwards, our ms or spin is -1/2. That's all.